We've been in the world of climate change, we've been in the world of ice, and now we move to water. So today's lecture is going to be the first in a series on hydrology, the study of water. And it's water in the atmosphere, it's water in rivers, it's waters in lakes, swamps, and groundwater, all of these different things. And we are not going to study all those. So atmosphere and rivers and lakes and swamps and groundwater. It's the chemistry, it's the physics, it's the flow, it's the erosion, the geology. All those aspects are the chemistry is all entitled within hydrology. We can't cover all that in a class like this. It would take a PhD to do it, but we're going to do rivers and groundwater here in this Intro to Geology class. In our opengeology.org textbook, this is chapter 11, and each of the different subsections have different aspects of this hydrology in the water cycle. Within today's lecture, I guess, of course, we could emphasize this idea of cycle, where there is the atmospheric part of the cycle with evaporation and precipitation, and then there's the groundwater and flow on the earth part of the cycle. So cycle, circulation, this is the process. Okay, so we got some big words today. And each one of them will be, of course, hard for me to spell and do penmanship. I need to make sure you understand evaporation. I need to make sure you understand transpiration. These are modes where, oh yeah, I'm doing a lot of TION words today. So these two are going to be ways that water leaves its liquid state and becomes a vapor. So both of these would be becomes vapor. And transpiration, this is going to be through plants and trees and leaves and photosynthesis process. In evaporation, this is just like through energy, sun energy, heat energy, that's making it go from the liquid state to vapor state. And once water is in this vapor state, it can travel very far, right? The winds of our weather blow this vapor around. And eventually we'll get to a situation where there is precipitation. Precipitation is when it becomes liquid. And again, that's not how you spell liquid. All right, so with precipitation, it's going to be condensation. That would be another good word here, condensation. And it's condensation to cloud, condensation to rain, and condensation to ice. And the way that precipitation occurs is we have to cool atmosphere. And so one thing we could say that there's a mechanism to cause precipitation, and it is rising air. And rising air equals cooling air. And cooling air can't hold as much water. In fact, for every 1 degree C, it's about 7% humidity. So as we drop our temperature, we drop our ability for the water to be held in the air, and then it will precipitate. And there's two main ways that rising air occurs on our planet. And so the first, it's called Hadley cell. And so here's our North Pole, here's our South Pole. We're looking at a big view of planet Earth. Here's the equator coming through the middle, and this is one way to make rising air. And Hadley cell is a global process where there's a latitudinal variation in terms of how much heat the Earth receives, right, from the sun. More heat is received at the low latitudes than at the upper latitudes. And at the same time, Earth is spinning on its axis very fast. And that creates these global weather patterns, global circulation patterns. And there is a pattern where hot air rises at the equator. And that is one of the aspects of a Hadley cell. And precipitation occurs. We could make some clouds here. Then the air circulates away and drops back down. And where it drops back down, air is very dry. Very dry. And this is where the world's deserts would be. There's another, let's see, the poles is another place where the air drops. Air drops near the poles, and it rises somewhere near here, rises, and so this would be another band, we would assume. Okay, global circulation patterns is Hadley cells driving rising air, cooling air, and precipitation. The other way to do it is with orographic forcing. And this is a very well named style. Oro means mountain, so this is mountain forcing of rain. And so if we have our ocean water and then the land rises up to mountains near the coast, we can have a situation where warm, humid air is blowing in off the coast and it is forced to rise up the topography. Otherwise, it's blocked by the mountain ranges. It can't be blocked because there's all this wind blowing it through. And so as the air rises, it will start to get colder and we get a lot of rain. And then on the backside of the mountain, we can actually have the air go back down and it's already been reduced from its water. And so this is going to be dry and it would be considered a rain shadow. So these are the two biggest reasons why there are bands of increased precipitation in certain areas on planet Earth. All right, that's one important concept of the day. The next important concept of the day is going to be the intersection with climate change. Like, this is a philosophical lecture in a lot of ways. So how does climate change impact the water cycle? And that is going to be a very simple answer, and very complex. But I want you to just know that we anticipate that climate change is going to intensify every aspect of precipitation. Droughts are going to be drier, rainstorms are going to be more powerful. Here's one projection I'll just show you about how, let's say 50 years from now, we're going to expect to see a change in precipitation. And so with this model, based on all sorts of data and supercomputer, it's going to have some areas of the world that they anticipate having less precipitation. In other areas of the world, especially near the equator, where we're going to have zones of much increased precipitation. We could look at similar images and projections based on evaporation and also drought. And the key to all of them is the highs are going to get higher, the lows are going to get lower, or the dries are going to get drier. So intensification is a result from climate change. The last concept for this introductory lecture is also philosophical, and it's one more of these words that end with a T-I-O-N, and I would like this one to be intersection. How does hydrology intersect with society or with humanity? Humanity. I think there's 5 different ways that we intersect with it. We're just going to list those out right here. And the first is going to be, I'm not sure if drought is the right word, or scarcity, or just use, but let's just put it as like water is a resource. And this encompasses a lot of them. And the question we're asking ourselves today is it a renewable resource, or is it a scarce resource, a finite resource that we could use and abuse? And the answer to this is very specific to where you live. It's very complicated, but in general, if we were to make an idea, it's about 70% of water and its use is a renewable resource, and about 30%, and this is going to change where you live, is a non-renewable resource that is finite and we could use and abuse it. Now, the ways that we are using it as a resource, this is going to be agriculture. I have this as its own heading. And what agriculture does is it changes the location of the water. Where the water would be a surface water or it would be a groundwater, we are changing its location and forcing it into plants. So we're going to say move to plants, which we need for food and for growing. But what this is going to do is going to move it to a situation where transpiration will affect that water. Sometimes we're taking groundwater that hasn't, well, we can get into all groundwater later. All right, another way that we intersect with the water cycle is through deforestation. It's kind of the opposite of agriculture in some ways. And here what we're doing is we're moving it away from plants. By removing trees, we also reduce transpiration. And that means we're going to have more surface water runoff. We might have more evaporation. It's a difference of how the water cycle will behave if we have significant agriculture in our region or significant deforestation in our region. And you should consider that these two often go together. We might deforest and then plant corn or something like that. Number 4, we could call this one diversions. And for diversions, I want you to think in this two ways. This is going to be dams, and this is also going to be aqueducts. Basically, we change aqueducts. Basically, we change the path of the water from source to sink. And by holding it or moving it, we change the local hydrologic cycle. And then finally, I'm going to put a picture in here. Yeah, this is good. A good summary. There's a huge dam, as you can imagine how this is changing the local hydrologic cycle. There's more infiltration, perhaps less runoff. What about all the sediment building up behind it? These are questions hydrologists answer. And this is an area where you can see the world without irrigation is yellow. Plants cannot be growing, but because of the miracle of pumps and irrigation, we can grow plants where plants should not grow. Okay, and then our fifth intersection with the hydrologic cycle is that we live in its way. And maybe we should say, let's just say it that way. We live in water's path. And in a world with more intense events, this is what one of the predictions of climate change, and in a world with more people, that means we're going to have more intensity intersecting with more people. And maybe the simple word to put here is flooding. We as a society are going to have to cope with flooding as we put more people in the path of water that is becoming more extreme in its highs as floods and also its lows as droughts.